Good afternoon everyone. I welcome you all to the JC eConnect series of lectures. Today, as a part of this series, I will be delivering a lecture on relative motion, which is a part of kinematics in your module 5. Hopefully, you have gone through the previous lectures and have made an effort to understand the contents. So let's start with today's lecture, which is on relative motion. So before coming to the exact topic, let us define some basic things such as say velocity. What is velocity? It is basically distance travelled upon time taken, or rate of change of distance, we term it as velocity. Then what is displacement? It is the movement of a particle or an object from one point to another. In simple terms, we can say it is a displacement or motion. So today we will be dealing with the concept of relative motion. So firstly, we will understand what is absolute motion. Now, if an object or a body is moving with respect to a fixed entity, that motion will be termed as an absolute motion. For example, a train is moving with respect to the platform. Here the platform becomes the fixed entity, whereas the train is moving. Now in this case, the movement of the train or the motion of the train is called as absolute motion, because it is with respect to the fixed entity, in which case the fixed entity is the platform. So now let's come to the second part, that is relative motion, which is our topic. If we define or if we consider a motion of any object or a body with respect to a fixed set of axes, or with respect to another object which is also under motion, we term that as a relative motion. Okay. For example, if two trains are moving and we are analyzing the motion sitting in one train, analyzing the motion of the another train, it becomes an relative motion. So a better way to understand it, this is like if your bus is moving and you have missed the bus and you run behind the bus to catch the bus. Now this becomes a relative motion, because your motion is related to the bus. You are not just running blindly, but you are running such that you can catch the bus. So your motion in this case becomes a relative motion. So here we can have relative motion in the same plane, or we can have relative motion in different planes. But here we are dealing with relative motion in same planes only. In this we can categorize the relative motion as say relative motion in same direction. The example which just I gave, the bus is moving ahead and you need to catch the bus. So of course surely you will also move in the direction of the bus, you will not move in the reverse direction. So this example becomes relative motion in the same direction. Now nowadays, as it's a curfew, you must have seen many videos also that police are chasing those people who are just roaming on the roads. Where are the police running? Behind those people. So it is which type of a motion? Relative motion. I gave this example because you must have seen various videos on Facebook or any other social networking sites. So that is what is relative motion in same direction. So here we have an example. In first case we have two trains, train A and train B. Both the trains are moving and their movement is parallel. Okay, their movement is parallel. Of course train won't run on the same track together. So here we have two trains which have parallel movement Both have a speed of say 75 km per hour. Now in this case, what becomes the relative velocity? Relative velocity is the difference between the two velocities, remember. So here if we want to find the relative velocity in this case, that is Vr equal to Va minus Vb. We are finding relative velocity of one train with respect to another, but in this scenario both the trains are moving with the same speed, hence the relative velocity becomes 75 minus 75, which is 0. Now let's come to the next case. Here also we have two trains moving parallelly, but first train has a speed of 80 km per hour, whereas the second train is moving with a speed of 60 km per hour. Hence, now how will you calculate the relative velocity? As I told earlier, relative velocity is the difference between the velocities of the two bodies. So, relative velocity here in this case becomes Va minus Vb, that is 80 minus 60, which is 20 km per hour. So, what you have to understand is, you have to see the direction of motion and you have to subtract one velocity with respect to other to get the relative velocity. Next is parallel but unlike, or parallel and the objects or the bodies are moving in opposite direction. Similar example is taken here. You have two trains, one is moving with the speed of 80 in one direction, say towards positive x-axis, whereas the other train B is moving with a speed of 60 in the opposite direction, say negative x-axis. So now in this case, how we find the relative velocity? Formula remains the same, that is difference between the two velocities. So here we get 80 minus of minus 60. Why we are taking minus 60? Because the train B is not moving in the same direction as that of A, but it is moving in the opposite direction. So its velocity comes along with the minus sign. One more minus sign is that which is there in the formula. Hence, what is the relative velocity in this case? It becomes 80 minus of minus 60, means minus of minus becomes plus. Relative velocity becomes 140 km per hour. So here firstly we discussed relative velocity of objects which are moving parallelly. Case 1 was same direction, case 2 was opposite direction. Now let's come to a concept of motion in a plane in any direction. Say A and B are two people or two bodies which are in the plane, but they start moving not in the same direction, but their directions are different. Okay, their directions are different. So now in this case, how we calculate the velocity? Let Va be the velocity of object or body A, Vb be the velocity of the object or the body B. Here we can use vector concept. The relative velocity of A with respect to B will be the vector difference as shown in the figure. Okay, so we can use vector method, or easier way is use graphical method. Don't worry much about this. These are just for the content, because the problems have been asked only based on the formulas. Next, the concept of relative velocity and resultant velocity. Now we come across here two terms. First term is a relative velocity, second term is resultant velocity. Now relative velocity we have defined earlier, velocity of one object with respect to another. Let's see now what is a resultant velocity. Imagine a boat is moving in water. It will have some velocity, say V1, but if that boat is moving along the direction of the flow, along the direction of the flow of water, the flow of water also adds up to the velocity of the boat. It gives the boat a push. So in this case here we get two velocities. One is the velocity of the boat itself, secondly is the velocity which is provided by the movement of the water, and both are in the same direction. So in this case we can easily get the velocity which will be the resultant velocity of the two, Okay, so we can get the formula as V is equal to square root of V1 square plus V2 square, where V1 is the velocity of the boat generated by its own engine, and V2 is the additional velocity which is provided by the flow of the water. So got the two concepts. One is relative velocity. Relative velocity is, again I am defining, it is the velocity of one object with respect to another object, whereas resultant velocity is combined effect of more than one velocities is termed as resultant velocity. So now just briefly let us see what are the differences. Relative velocity is the velocity of a body as observed from a moving object, whereas resultant velocity is combined effect of two or more forces causing motion in a same body. Secondly, relative velocity of the body is vector difference of the velocities, whereas the resultant velocity is obtained by vector addition. That means when we want to get relative velocity, we take the difference of the velocities, whereas when we want to take resultant velocity, we take addition of the velocities. Okay, so this is the concept of relative velocity and resultant velocity. So let us discuss a simple problem. It's a very simple basic level problem, just to further understand the concepts in detail. In this problem we have two trains. One is of length 100 meters, second is of length 80 meters. Okay, say train A is of length 100 meters and train B is of length 80 meters. Both are moving along parallel tracks in like direction. In a sense, both are moving on parallel tracks in the same direction. Now it is observed that it takes 15 seconds for one to cross over other. Okay, what is observed is it takes 15 seconds for one train to cross over the other train. If the train of greater length moves with the velocity of half that of the other, find the speed of each train. So here we want to find the speed. So basically reading of the problem using lots of common sense is required. Further solution will be easy. So as I said earlier, let the train A be of length 100 meters and let the train B be of length 80 meters. So what does the velocity given data say about velocity? If say V is the velocity of train B, which is the shorter train, then velocity of train A, which is the longer train, is V by 2, because in the statement of the problem what is mentioned? The train of greater length moves with the velocity half that of the other. Means if velocity of B is defined as V, velocity of A will be V by 2. Next, this is the schematic or diagrammatic representation wherein the moment of A is shown, where VA is specifically velocity of train A, which is half of V. VB, which is specifically the velocity of train B, which is equal to V itself. So now, as per our formula of relative velocity, let us find relative velocity of B, because it is moving faster with respect to A. We will name relative velocity as VR. VR is equals to difference between both, that is VB minus VA, which comes out to be V minus V by 2. Your answer is V by 2 meter per second. Okay, so now here we have to find what is V. Then next important concept, when you can say that the shorter train has completely overtaken the longer train, when it covers the entire distance of the longer train and the last bogie of the shorter train just crosses the engine of the longer train, you can say that the train B has completely overtaken train A. Okay, again I am repeating, when you can say that train B, which is moving with a velocity V, has completely overtaken train A, when train B crosses entire length of train A and the last bogie of train B is just ahead of the engine of train A, we can say that train B has completely overtaken train A. So for this to happen, how much will be the total length covered? 80 meters of train B plus 100 meters of train A, which is 180 meters with respect to the slow moving train. Okay, so total distance covered for overtaking will be 180 meters. Now, in the given data, it is mentioned that 15 seconds are required to overtake. That means that 180 meters distance which the train will cover, train B will cover to overtake train A completely is done in how many seconds? 15 seconds. Now, here we can use the formula for velocity. Velocity formula is what? Distance travelled upon time taken, or what we have with us? We have distance with us, we have time with us. So here how it is given? Relative distance we have cross multiplied and taken velocity into time. Therefore, substituting the required values, relative distance is distance of overtaking, which is 180 meters. The relative velocity as found above is V by 2. The time required for this process to happen is 15 seconds. Therefore, when we cross multiply 180 into 2 divided by 15, we get the answer as V is equal to 24 meter per second. Therefore, speed or the velocity of the shorter train is 24 meter per second, whereas velocity of the longer train as per the given relationship is V by 2, which is equal to 12 meter per second. Hence, our answers are speed of train A 12 meter per second, speed of train B 24 meter per second. As simple as that. You can keep it in the same unit, or generally we define speed in terms of kilometer per hour, convert meter to kilometer, convert seconds to minutes. So this is what is the concept of relative motion. This was a simple example which I took up with the concept so that you will understand what we are trying to learn. So I will summarize the class. This is a class where we are studying relative motion. We have defined what is relative motion. We have gone through two types of relative motion. One is like, one is unlike, in which objects are moving parallel. In first case it is same direction, second case it is opposite direction. We got the formula for relative motion, which is the difference of the velocities of both the objects. Then we went to the concept of what is resultant velocity what is resultant velocity and what is relative velocity. Then we have made an attempt to apply those concepts in a simple problems. So I request you all to go through this basics, which are quite easy, so that tomorrow we can go ahead with more number of examples. Please go through all the previous videos and make your concepts clear by discussing with the staff that day itself, or at least in those 2-3 days before a new concept or a new chapter starts. Thank you. I wish you all a healthy and a happy stay at home. See you for the next lecture on Monday. Thank you.